Hello everybody. Welcome to our first objective of Geometry A, measuring segments and angles. Okay, really foundational stuff here. In geometry, every shape we look at is going to be made up of line segments and angles. So the better we are with just the basic pieces here, the better we are going to be moving forward through the rest of geometry. Okay, so let's get going with objective 1 here. Now we've got a lot of vocab to go through in this section. And really, it's vocab words we're going to be using all the way through geometry, through the rest of geometry. So important stuff. We'll make sure we touch on it all. First off, let's talk about a segment. I'm going to say it's part of a line that consists of two endpoints and all the points between them. Now in geometry, we're going to assume a line is something that goes on forever in both directions. Okay, so what I see here is a segment. If it was a line, we'd have arrows that continue in both directions. Okay, there's the endpoints A and B. The segment is everything between those two endpoints. Okay, as far as naming, you can name a segment by its two endpoints in either order. So I call this segment AB or segment BA. Either order works. Notice the segment symbol on top of the name. And then the length of the segment is the distance between the endpoints. So here, if this distance is 3 inches, I'd write that as AB without the segment symbol above it. That stands for the length of AB. I can say that's equal to 3 inches. Next thing we'll talk about is something called the segment addition postulate. This just says that if 3 points A, B, and C are collinear, so I have A, B, and C on the same line, and B is between A and C, okay, so B is in the middle somewhere, then the length of AB plus the length of BC is equal to AC. So in other words, if I have a larger segment AC and it's made up of AB and BC, if I add the length of AB plus the length of BC, I'll get AC. Okay, this is a postulate, just something we'll assume to be true, and it's going to show up in a lot of different problem solving we do throughout geometry. Alright, so let's go ahead and use that segment addition postulate. And this question is really designed to put your understanding of what a segment is, okay, how its measurement works, okay, how that postulate works, kind of all to the test here. So we're given a segment with some different points on it, and it says that if EG is equal to 59 units and EF is equal to 34 units, what is FG? Okay, so we want to know what FG is. And we're given that EG, the length of the entire segment here, is equal to 59. And EF, okay, my first smaller segment is 34. I want to use that information to figure out what my missing part is here, FG. Okay, now notice with my picture I marked the actual lengths on them. It'd be nice if the problem gave us that, but if it ever doesn't, you can always put them on yourself. Okay, well, how are we going to figure this out? Segment addition postulate said that EF, the first part of the segment, plus FG, the second part, is equal to the whole thing, EG. And if I fill in what I know EF is 34. FG is the part I'm looking for, but 34 plus FG is going to be equal to EG, the whole thing, 59. So what I have here is a simple equation to solve, and essentially if I just subtract the part from the whole, that's going to give me the other part. So we could say FG is equal to 25. Okay, that's one example of using my segment addition postulate to find parts of a segment. Now, I could give you the two smaller parts. I could give you the bigger part and one of the smaller parts, like in this one. We'll mix it up on as you go through the section. Okay, but problem B is the same type of question, some information about the segment addition postulate. Take a minute, pause the video, work through that one, throw a hand up and get your answer checked, and then you'll be able to move on to the next question. Next thing we're going to talk about is actually measuring segments. We're going to say the distance between point AB, so the distance from points A to B, written as just AB, is the absolute value of the difference of their coordinates. Okay, so this isn't a great picture here, but if I have a number line, and I know that point A is at coordinate A, and point B is at coordinate B, what I can do to find their length from A to B, is just take the absolute value of the difference of their coordinates. In other words, subtract their coordinates, can make whatever we have positive. All right, that absolute value is there just so I don't need to worry about what order to subtract the coordinates in. Okay, it'll always give me a positive distance, okay, because we know distances should be positive. So problem 2, we're measuring segments. Part A wants to know what is ST. Okay, remember when I say what is ST, that means the length from S to T along this number line. Okay, so the length of that segment. And basically a number line is going to work like a ruler, except for with a number line, instead of starting at 0, I can go into negative values. Okay, I could have a segment that runs just between positive values. That's kind of the point of that equation we just gave you. Okay, to kind of make calculations easier. All right, so we said that ST is just equal to the absolute value of the difference of my coordinates. So S is at -4. So we'll go -4 minus the T value, which is at 8. Okay, -4 minus 8 would be a -12, so the absolute value of -12, okay, which is equal to 12. Remember, the absolute value makes our positive numbers positive and negative numbers positive as well. And again, the reason I have the absolute values, I don't need to worry about what order to subtract these in. I'll always get the positive answer. Okay, not a bad idea if you've got a picture come test time. Okay, we can just count things out to double check. 2, 4, 6, 8, 10, 12. Yep, looks like we're good. Okay, but it's important to be able to use that formula as well. All right, problem B is another question, measuring segments with the same number line here. Once again, take a minute, pause the video, work through that question, and then check your answer before we move on. Okay, next thing we're going to talk about is the idea of congruent segments. I'm going to say congruent segments are two segments that have the same length. So let's say, for example, that segment AB and segment CD both measure 1 inch. They're both 1 inch long. Okay, that means that the length of AB is equal to the length of CD. But I'm not going to say that the actual segment AB is equal to the segment CD. They're different segments, they're not the same thing. Okay, if I want to express the two segments have the same length, what we'll do is we'll say they're congruent with this congruent symbol here. Okay, an equal sign with a squiggly line on top. Okay, so this reads as segment AB is congruent to segment CD. Now, as far as marking congruent segments, what we'll do is we'll put an equal number of tick marks on the two segments. So since both of these segments, A, B, and CD, have a single red tick mark through them, I know they're congruent. Now, or if they both had 3 red tick marks through them, I know they're congruent as well. Okay, that'll be a way we can show congruence without it showing the actual length like we have on the left here. So let's go ahead and use that idea of congruence. Okay, problem 3, part A, says which segment is congruent to segment AB. In other words, which segment has the same length as AB. So AB is my segment from -2 to +1. All right, it's short enough and I have the picture, so we'll just count that off. We've got a length of 2, 4, 5. And what I need to do then is figure out which other segment has that same length. We'll just kind of eyeballing it, it looks like CD does. Okay, let's see here, 2, 4, 5 as well. Yep, so I could say that AB, segment AB is congruent to segment CD. Okay, again, because they have the same length. All right, that's part A. Once again, give part B a shot, pause the video, give that a shot, and then check your answer before you move on. Next thing we're going to talk about is the idea of a midpoint. I'm going to say a midpoint is just a point that divides a segment into two segments that are equal in length. In other words, two segments that are congruent. In this picture here, we have B as the midpoint of segment AC, and we're showing that to you by giving an equal number of tick marks to segments AB and BC. We're showing those two segments are congruent. Therefore, B has to be in the middle and be the midpoint. So let's look at using that idea of a midpoint. Okay, similar question to the first one we started off with. This one says that Q is the midpoint of segment PR. If PQ, or the length of PQ, is 7, what are QR and PR? Okay, so right off the bat, we're given that Q is the midpoint, okay, meaning that PQ will be congruent to QR. Now again, I'm going to mark up this picture with anything that'd be nice to know. We're given that PQ is equal to 7, and since Q is the midpoint, that means that QR is 7 as well. So we know that answer right off the bat. QR is just equal to 7. And then so also we don't know what PR is. Well, that's just going to be 7 plus 7, adding those two congruent parts together, which will give us a 14. Okay, once again, there's some different ways I can mix this up on you. Maybe I give you the first chunk, maybe I give you the second chunk, I can give you the whole thing. All right, the whole idea here is that if we know we have a midpoint, we know how the overall segment will be split up. Okay, again, pause the video, give part B a shot, check your answer before you move on. The last thing we're going to do with segments is look at actually calculating the coordinates of a midpoint. So for this one, it says that segment AB has endpoints at -4 and 9, as shown in my picture down here. We want to know what is the coordinate of the midpoint. Okay, so let's call our midpoint M. Now when I say midpoint, think middle, think average of my two endpoints. So what I'll do to find the average is I'll add their two coordinates together. We'll add -4 plus 9. And then to find the average of two numbers, we'll just divide it by 2. So calculating that, -4 plus 9 is 5. So we have 5 divided by 2. And 5 divided by 2 is just 2.5. Okay, not a nice number, but that's okay. So my midpoint M, we could say, is at coordinates 2.5. And if I go up to my picture and kind of eyeball where that's going to be, well, here's 3. So 2.5 would be about here. Whoops. Yeah, visually it looks like that checks out. Okay, it looks like we found the correct midpoint. Okay, problem B in the note guide is also a midpoint question. Take a minute, pause the video, work your way through that one, and then check your answer before you move on. Now the other half of this first objective is going to deal with finding angles in their measures. And a lot of what we do with angles is going to be very similar to what we just did with segments. Okay, so first off, let's define an angle for you. We'll see an angle is formed by two rays with the same endpoint. So we're not going to get too technical on what rays are, but rays are just basically arrows pointing in one direction. Okay, so I have the ray AB and the ray AC. They both have the endpoint at A. Okay, we'll say the rays are the sides of the angle and the endpoint is the vertex of the angle. And you can name an angle by several ways here. Number one, just its vertex. Okay, so we call this angle A. Now, if the vertex alone won't be specific enough, you have to use either 3 letters. Okay, so you could name it as a vertex and a point on each ray. So as we call this angle BAC or CAB, notice in both cases the vertex was in the middle of that name. Okay, or in some cases we'll just name it with a number. We call this angle 1. Okay, all those are going to work better or worse in different situations. We'll see them all as we go through here. And then just like we have the segment addition postulate for segments, we also have the angle addition postulate. It just says that if point B is in the interior of angle AOC, so if I have the larger angle AOC with B on the interior, which essentially splits that into two different angles, then M angle, as in the measure of angle AOB, plus the measure of angle BOC is equal to the measure of angle AOC. So in other words, if I add these two smaller angles together, I'll get the same measure as the whole thing. Okay, again, it's a postulate. It's something we'll just kind of accept as true. And again, they'll be important as we do a lot of different problems where we're solving for angle measures as we go all the way through geometry. So let's go ahead and put that angle addition postulate to use. So problem 6, part A says if the measure of angle ROS is 72 degrees and the measure of angle SOT is 83 degrees, what's the measure of angle ROT? Okay, so just like we did with segments, let's mark up this picture. Let's fill in the values we know. And the measure of angle ROS is 72. Well, as far as that goes in the picture, if I find R, O, and S, those 3 points, that angle is going to be the inside here. So I have 72 degrees. And then angle SOT is 83. So SOT is 83 degrees. And I want to know the measure of angle ROT. In other words, we want to figure out the measure of this entire angle made up of the 2 smaller angles. Well, that's simple to calculate. We'll just add these 2 parts together. We could say that the measure of angle ROT is equal to 72 degrees plus 83 degrees, which will give us a 155 degrees for a total. Just like with segments, I could give you the whole thing, you could have to find a part, or I could give you the 2 parts, you can find the whole. There's some different ways we can mix this question up, so there are some problem-solving skills you have to use with it. Okay, just like I did here, when you're given that information, fill it in on the picture. That's going to make life a lot easier as you go through these. Okay, once again, give part B a shot in the note guide, pause the video, work through that one, and then check your answer before you move on. Now, just like we have the idea of congruent segments, segments with the same length or the same measure, we also have congruent angles, and we'll just say those are angles with the same measure. Okay, so if I have angles A and B and they have the same measure here, rather than saying the measure of angle A is equal to the measure of angle B, we can just say that A is congruent to angle B. Okay, same congruent symbol, equal sign with a squiggly line on top. And again, that's just a way to talk about 2 angles having the same measure. Now, as far as marking congruent angles up goes, I'm going to say these 2 angles are marked congruent since they both have an equal number of kind of arches on them. So if they both had, same idea, 2 arches, we know they're congruent. Or if they both had 3, we know they're congruent. Okay, equal numbers of arches will be how we represent congruence for angles. Now, an important skill to have is going to be being able to identify congruent angles in our diagrams. And that's what we're doing in problem 7. Part A says which angle is congruent to angle WBM. So based on these markings, we want to figure out which angle has the same measure as WBM. Well, if I trace W to B to M, I can figure out which angle we're talking about here. And since WBM has a single arch on it, what I can do is I can match that up with the other angle with a single arch. Okay, that single arch is just right here. So that means it's congruent to this angle. So I could say that angle WBM is congruent to angle, well, we could say YEB. Okay, just picking any one of the points on its 2 rays. Okay, or I suppose I could mix that up and say angle AEM. Okay, or I could flip the order around, or I could use the D instead of the B or the M. Okay, so there's some different ways to name that, but either way we're talking about this angle with a single arch. Alright, once again, give part B a shot. Okay, pause the video, work through part B, and check your answer before we move on. Next thing we're going to talk about are a couple of special types of angle pairs: complementary angles and supplementary angles. We'll say that complementary angles are 2 angles whose measure have a sum of 90 degrees. Okay, so for example, angles 1 and 2 we'd say are complementary because when they come together they make this right angle here, this right angle box. And usually when we're talking about complementary angles, we're talking about two adjacent angles that form a right angle. But since angles A and B, which are 47 and 43, add to 90 as well, we'd say that angles A and B are complementary also. Supplementary angles, we'll say, are two angles whose measure have a sum of 180. And we'll be able to see that because when two angles add together to make 180, they'll form this straight angle, this straight line. Okay, so anytime I see two angles coming together to form a straight line, like angles 3 and 4, we'll know they're supplementary. Okay, or it'd be less common, but if I have two angles just floating off in space, when I add them together, okay, for example, the 137, the 43, those will give me 180 as well. I'd say they're supplementary as well. So let's go ahead and use those definitions for complementary and supplementary angles. So we have our geometric figure on the right. We'll do both these problems together. Part A asks, what is the measure of angle CFD? Well, let's find that angle first. CFD is going to be this angle on the right here. And the trick for finding this angle measure is me recognizing that I have a right angle from this right angle box. Therefore, the angles that make it up, BFC and CFD, will be complementary to each other. They'll add to 90. So to find CFD, I'll just take 90 and subtract the 28 from BFC, which will give me 62 degrees for a total for the measure of angle CFD. So there's an example using complementary angles within a geometry problem. So part B then is going to be a supplementary problem. It says, what's the measure of angle EFD? Well, E to F to D is this angle on the bottom here. And the trick for doing this one is recognizing that angle AFD forms a straight line. Therefore, it is equal to 180 degrees. So AFE and EFD will be supplementary. So for the measure of angle EFD, we'll just take 180 minus 62. And notice I could do that with the angle AFE, which is 62 on the left, okay, or the CFD, which is 62 on the right. Either way it'd work. Now when I go 180 minus 62, that's going to give me 118 degrees. Okay, the supplement for either the AFE or CFD. And the last thing we're going to talk about in this lesson is the idea of an angle bisector. I'm going to say it's a ray that divides an angle into two congruent angles. So in this case here, in this diagram, ray AY is my angle bisector, okay, because it splits the larger angle XAZ into two congruent angles. Okay, you can see they're marked congruent here. Okay, so we'd say it bisects XAZ because it splits it into two congruent angles. So let's go ahead and use that idea of an angle bisector. Problem 9 part A says that AC bisects angle DAB. Okay, so in other words, this ray AC splits our larger angle DAB into two congruent angles. And this picture's already got those marked congruent for us. It then says if the measure of angle DAC is 58, what is the measure of angle DAB? Okay, so filling that into our diagram, DAC is 58, D to A to C here is 58 degrees, and I want to know what's the measure of angle DAB. Well, again, since ray AC is an angle bisector, I know both the left and right angles will be equal. They'll both be 58 degrees. Okay, meaning that the measure of angle DAB is just equal to 58 plus 58. In other words, 116 degrees. Okay, so there's an example of using an angle bisector in a problem. Again, kind of similar to our angle addition postulate. Okay, kind of similar to what we did to the midpoint with the segment addition postulate as well. Okay, there's also a part B to this one. Okay, video's over, but go ahead and work through that one, check your answer, and then once you're done with that, you can move on to the Math XL and get some individual practice in.